Now let's talk about graphing quadratic functions from any of the forms of the equation. So vertex form is what we used last time, so you should be very familiar with this form of the equation. And we have an h value and a k value that we can pick out. Our h value in this case, our vertex, is at 3, remembering that there is a negative in the equation here. And so when we see a negative, it's actually positive. And 4 is our y value. So this is our h, comma, k. Our axis of symmetry has to occur at the h value. So it's at x is equal to 3. So we can draw our axis of symmetry at x equals 3. And we can plot our vertex at 3, 4. We can also pick a couple more points off the graph. If we go to the left by 1 in the x direction at a value of 4 here, so plug in 4 for x, 4 minus 3 is 1, square that, still 1, put a negative on it, so now it's negative 1. Negative 1 plus 4 gives me a value of 3. So at 4, I can plot the value of 3, and remember, because of the axis of symmetry, I can go across and plot on the other side as well. We could continue plotting points, but that's probably enough to get a general shape of what our graph looks like, something like this. Now let's look at standard form of the equation. So remember that that's ax squared plus bx plus c, and so our a value is negative 2, our b value is negative 4, and our c value is 6. We can calculate the x value of the vertex. Remember that that's the same as the axis of symmetry. So I'm going to jump down here and do axis of symmetry first and then come back to vertex. So our x value of our vertex, which is also the axis of symmetry, is at negative b over 2a. And so my b value is negative 4. So this is going to be the negative of negative 4. And then 2 times negative 2. And so I get a value of negative 1. So x equals negative 1 is my axis of symmetry. Remember that that's actually also the x value of my vertex. And so to find the y value of my vertex, I'm just going to plug in a value of negative 1 everywhere that I see x in the equation. So y is equal to negative 2 times negative 1 squared minus 4 times negative 1 plus 6. If I simplify that, negative 1 squared is a positive 1 times negative 2 is negative 2. I get a plus 4 and a plus 6, and so all of that comes out to be 8. So my vertex is at negative 1, 8. So I can plot that, negative 1 and 8. Ooh, I'm actually a little bit off the graph, but I can estimate it to be about there. Finally, remember that I can get my y-intercept easily from the equation here. It's the value at c. So my y-intercept is going to be at 0, 6. So at 0, 6, I can draw a point, and by symmetry, I can put the point on the other side and use that to estimate the shape of my parabola, like this. Now let's graph from intercept form. We have a p value and a q value that give us our intercepts, but remember that we have these negative signs built into the equation. So whatever we see, our p and q value are the opposite. So p is actually equal to a positive 3, and q is equal to a negative 1. My axis of symmetry is calculated easily from this simple equation. I'm going to skip vertex for the second because the x value of my vertex is the same as my axis of symmetry. So it's x is equal to p plus q over 2. That's a 3 minus 1 over 2, or it's a value of 1. So x equals 1 is my axis of symmetry, and I can draw that here and label it as AOS for axis of symmetry. Now that I know the x value of my vertex, because it occurs at the axis of symmetry, I can calculate y. So y is equal to -2 times 1 minus 3 and times 1 plus 1. That's going to simplify to be, let's see, this will be a -2 and this will be a +2. -2 times -2 times +2 is a +8. So my vertex is at 1, 8. And I can plot that. Again, looks like we're a little bit off our graph, but we can do that right there. Remembering that we can easily pick out our x-intercepts from this form. With a p-value of 3, I get the point 3, 0, and my other x-intercept is at -1, 0. So if I plot those 2 points, now I've got some points on my graph where I can see what my parabola is going to look like. This one's kind of a long, skinny one.